Okay, YouTube, in our last video we discussed how to evaluate composite functions, that is plugging a function into another function. In this video it's basically an extension of the last one in which we're going to talk about what values to exclude from the domain of a composite function, or like f of g of x. What would its domain be? And so here are the important bits of news that I need to get across. We say the following values must be excluded from the input of x, the very first of which are the x values that are not in the domain of g. We have to exclude that from the composition. Okay, so basically, if this inner function right here has any x values that when you plug them in cause it to either be not real or undefined because you're dividing by 0, we should take that out of the domain, because you're not going to get f of g of x if you can't even get g of x in the first place. Now, the second stipulation here is that any x we're going to exclude here, any x for which g of x is not in the domain of f must not be in the domain of f of g. So in other words, any x values for which our g of x values are not in the domain of f. So essentially, we're plugging g of x into f. So g of x, its values are actually the domain values for f. The weird thing about this is that g of x are the domain values for f, but g of x are also the range values for g, the outputs for g. Excuse me, very sorry. So those are the output values for g. So we need to check, are there any range values for g of x that can't be in the domain for f of x? And so what I've done is I've listed an example that I got a screenshot of down here. We say given f of x is this 4 over x plus 2 and g of x is this 1 over x, find each of the following. So we're going to start by finding f of g of x, which I'm going to rewrite, which is just the smartest policy. F of g of x. It looks like we're plugging g of x into f of x. So when I plug into f of x, remember our rule says 4 over our input plus 2. And so in this case, what we're plugging in is g of x. Okay. So now, g of x is 1 over x. Now, I'm also plugging it into f of g here, but g of x being 1 over x, the thing we want to recognize here is that x should not be equal to 0. That is to say that if we allow x to be 0, that f of g of x will never even get a chance to get off the ground, because g of x never had a value in the first place. So what we're going to do is this. We're going to break this finding the domain down to a specific process. And step number 1 is this. Find the domain of the inner function. When you find the domain of a composite function, you always start by finding the domain of the inner function g of x. So we've started by finding the domain of the inner function g of x. Now the next part is going to be this. Let's find the domain of the new composite function. So our new composite function, which we haven't finished evaluating yet, which was this 4 over g of x plus 2, we'd say its domain would be all values for which this is not equal to 0. So what we're going to do is we're going to grab that expression g of x plus 2, we're going to set it equal to 0. I'm going to say, well, what would cause this to be true? We would say that, well, g of x would have to be equal to negative 2. So finding the domain of this, we use the expression g of x abstractly here. Not abstractly, but in general, instead of actually plugging in what g of x equaled. But this was good enough for us to see that g of x should not be allowed to be equal to negative 2. So what we're going to do now is we can actually substitute in for g of x here its expression. And what we end up with is something that we can solve backwards for x on. Okay, so we're going to take both sides of this equation times the least common denominator here, which is x. And in this case, we would get our x's to cancel, and we would get 1 on the left is equal to negative 2 times x, and now dividing both sides of this by a negative 2. We end up with x equals negative a half. So we would say that the domain of this outer function, or this new composite function, is x is not allowed to be negative a half. So we would say now that I have the domain of the original function and the domain of the composite function, phase 3 of our plan here is going to be this. The domain overall, or the overall domain, is the intersection, or the overlap, of these two domains. So let's talk about the reasoning behind this. Basically, f of g of x, the domain of this, let's write it. We'd say it's all real x values, except for what did we learn? We learned that x shouldn't be allowed to be equal to 0, because if so, g of x, the inner function, would be undefined. And then also, x should not be allowed to be equal to negative a half. And the reason why is because if that is true, then g of x is going to be equal to negative 2, which is a restricted value in this new composite function, okay? So we would say that we have an overlap of these two domains as all real numbers except for these two together, even though each one individually only restricts one or the other. Cheers.